In this video, I want to talk about scalars, and vectors. Alright, a scalar and a vector are fundamentally different because a scalar is by definition a number. Okay, scalar is by definition a number, and a vector, okay, written by this notation, is defined as something with a magnitude, okay, and a direction, A vector can have several components, so because it has a direction, it has either an x and a y component, or it has an x, a y, and a z component. In higher level mathematics, you can actually add multiple components to it that are more than 3. But in physics, we're only going to see 2 to 3 components of a specific vector. Now just remember the difference between a scalar and a vector is that a scalar is a specific number. It's just a number, and a vector, okay, has a magnitude and a direction. So scalar is just number, vector is magnitude and direction. Now with that fundamental truth in mind, we know that the magnitude of a vector, of some vector, is equal to the components of that vector. So we have x squared plus y squared plus z squared dot 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 dot. And the square root of the sum of its components will equal its magnitude. So you can theoretically have multiple components to it, but in this idea we have the square root of the sum of all of its components, x, y, and z, will give you the magnitude of that specific vector. And the direction is calculated by, if you have a vector, and you have its x component, its y component, its direction, theta, is calculated by its x and y components. Alright, so if you had an x here, a y component here, of this vector, alright, I'm going to call this vector 1, you can find the y component because of the sine of theta times the vector. It's going to equal the vector's y component, okay, and the cosine of theta times the vector is going to give you the vector's x component. And these are actually scalar numbers. The individual components are going to give you scalar numbers. Okay, scalars. When you multiply the sine of the specific angle of the direction of this vector, you're going to get scalars. Alright, now with that concept in mind, we're going to expand on that, alright, and we are going to go with addition of vectors, I'll just put addition, multiplication, or cross product, and dot product, so dot product, and cross product. Now in the next video, and the videos following that, I'm going to go over addition, dot product, and cross product with respect to the concept of vectors. And we're also going to talk about how if you multiply a scalar times a vector, you're going to get a vector. But if you multiply two vectors together, take the dot product, you're going to get a scalar. And if you take the cross product, you're going to get a vector. Alright. So, with that being said, I am actually going to first describe a little bit more about magnitude.